At some of these level 1 questions, I'll give you some tips. Remember, you should watch the previous video if you are totally lost and you don't know what to do. That walks you through exactly how to do all of the problems that are on the back of your note sheet, on the back of this. So make sure you know how to do these first. There's a video to walk you through that. This video right now is just to walk you through or give you some tips on how to do these. So you found a rock that contains that much percent of its original. How many half-lives have passed? You should be able to do that. Remember, draw out the table, right? You should know this from the previous video. Found a rock that has this much. How old is the rock? That's just the next level. In order to do this one, the second problem, if it has 25% of its original carbon-14 first, I'll write these tips here so you remember. First, find how many half-lives. How many half-lives is that? Then once you know the half-lives, and you know how long one half-life is of carbon-14, you can just do simple multiplication to figure out how old the rock is. If 3 half-lives went by, then 5,730 years times 3, right? Watch your previous video, it's easy. Now you find a rock, now we're talking about grams. It tells you that you have 20 grams and 2 half-lives have gone by. How many grams of uranium did the rock originally have? So this is a little bit different. So now instead of looking at percents, they tell you that you had 20 grams to begin with. And so for this one, we kind of have to work backwards. Let me see what we got here. So let's work backwards. So it's telling us we have, let's say, I want to do a different problem because I don't want to give you the answer. Let's say you had 40 grams and 3 half-lives went by, right? All right. So we can still make our table, except this time we're not going to fill it all out. We have grams of the parent isotope instead of percent. We have half-lives. They are giving us some information. They know 3 half-lives went by. We know, 3 half-lives went by. So we know that 2 and 1 half-life has gone by. 1, 2, 3 half-lives. And we know that at 3 half-lives, there was 40 grams. Right? So we just have to kind of work backwards. If there was 40 grams at 3 half-lives, how many were there at 2? So it has to double to go back, right? Because if there's 4 half-lives, we know if we had 40 grams at 3 half-lives, then at 4 half-lives, there'd be 20. So we're working backwards. So 40 times 2 is 80 grams at 2 half-lives. How many were there at 1 half-life? Well, 160 grams. How many was there when it first originally started? 160 times 2 is 320. So this one ended up 320. So we know that there was 320 grams at the start, or we can also say at 0 half-lives. So you just kind of have to work backwards for this one, right? How many grams did it originally have? We just did that one. I didn't give you the exact answer. They're asking for 20. I did an example for 40. So don't give me this answer. I just showed you how to do it. You have to work backwards. It's like a puzzle. Last level 1. You found a rock that has 4.5 grams of potassium-40. It originally had 36 grams of potassium-40. How many half-lives have passed? Interesting. So I'll do one just like this. Let's say they told you that you have something that has 2.5 grams of potassium-40. Notice this 40 is just what the name is of the isotope. It has nothing to do with the time. So don't confuse that. Don't just assume that. We have 2.5 grams of this. Let's say that they tell us that it originally had 10 grams of P40, potassium-40. All right? Not the same question, right? They told you it has 4.5 grams of potassium-40 and originally had 36. I'm not going to do the exact question because I don't want to give you the answer. But I'll do one exactly like it. They tell you that it has this much now, but it started with this much. So they want to know how many half-lives have passed and how old is the rock. So we have to figure out how many half-lives have to go by to go from 10 to 2.5. We can make our table. We know, and we're not going to do percents here. We'll do grams again of parent isotope and time. We know that it started with 10 grams. That was at 0 half-lives and 0 time. So how much was there after 1 half-life? What's half of 10? 5. All right, we're not there yet, so it's definitely more than 1 half-life. What's half of 5? 2.5 grams. That's after 2 half-lives. Oh, for my example here, we got there. We know that there's 2 half-lives have gone by. Boom, first answer, done. But you're not done. How old is the rock? Now we got to use the table. So potassium 40, we're using this here, is 1.3 billion years. So we know 1 half-life was 1.3 billion years. What was 2? Well, it's 1.3 plus 1.3, 2.6 billion years. Or we could just do 1.3 times 2, right? Still gives the same answer. Okay, that's how you do that problem. Remember, I didn't do the one on the worksheet. I did one that's just like it, but this one's a little different. Same process. If you have questions, just ask.